We are live. Live, I say.
Live, you say. We did it.
Yes. Did you see there's a new version of Frankenstein's wife that's coming out that is being done in the style of a fairy tale?
No.
Yeah, Emma Stone is in it, and
Oh, great.
it looks
Okay.
very, very pretty. I
Hmm.
can't say how the plot or anything will be, but it already has Oscar buzz and hasn't even really started.
Apparently, the new Spider-Man multiverse movie is terrific.
That's what
Like
I've heard
everyone,
too.
I'm seeing so many people saying it's like the best movie of the year.
Really? That
Yeah.
I hope
By
that
any measurement. Like sober economists are saying it's the best movie they've seen all year. So it sounds terrific. We watched Avatar this weekend.
the Way of Water,
Yeah, that's
that
a
so did
slog.
I.
Yeah,
Yeah.
yeah. Boy, that took a while.
Like
3.5 hours?
yeah, like we put it on at 9 p.m. thinking, yeah, we have ice cream. We'll eat the ice cream, we'll watch the movie, assemble a little bit of Lego,
Yeah.
and then like slowly became one with the sofa.
Yeah. Yeah. You're like, I gotta go pee. I'll also go pee. And then you're like, go get
Yeah.
more snacks. What have you got? Some more snacks? Okay. Right. Back at it. All
Yeah,
right.
yeah, it was pretty.
Yep. Yep.
It was a reminder that James Cameron's real expertise is film technology.
Mm-hmm. Mm-hmm.
And I know Kate Winslet was in the movie, and I have no idea which character she was.
Yeah, I know. I saw that too. We saw that. You're like, wait, what? She was in the movie?
So
Yeah.
confused.
Yeah.
None of them were British.
I think the part that's amazing about that movie is that it's so seamless now
Yeah.
that you're not amazed by the technology. And I'm sure if you watch with James Cameron, he'll be like, that scene right there, you see that? Like they're inside this ship and the water is rising up inside the ship, and yet you've got a giant blue guy running around. Like that took us 3 months to film because it's practical and it's giant sets are being like crazy. So yeah, it's a and like we won't even know
Yeah.
what parts were easy to do and which parts were hard to do. It's all so seamless. So big scenes where they're out swimming around in the water and like kind of like Finding Nemo. Like was that that's
Right.
that's 20 years ago. They kind of nailed that technology. So yeah,
It
but
the thing that really got me about it is they still randomly wander into the uncanny valley, but the percentage of the time spent in the uncanny valley is asymptotically approaching zero.
yes, yeah, we are the uncanny valley is behind us now as we
Mm,
continue on the
not
road to
quite
the
behind
future.
us. There are still mistakes that get made now and then.
So are we passing on the upslope of the uncanny valley? Are we starting to exit the uncanny valley? Like I feel like we're seeing like seeing artificial intelligence take on these kinds of tasks. It comes at it in a way that doesn't trigger the uncanny valley in the same way that it being rendered by a human being.
Polar Express. We are past Polar Express
Right,
ever
and the Polar
happening
Express
again.
was like manually people trying to make realistic human beings, and instead you just look like you have these lurching ghouls,
It was so
right?
bad. So
But the
bad.
AI, the way they make, like when you look at like the way the AI makes video, it looks like, have you seen some of these ads where it's like beer commercial and yet it's generated by AI and
Still
it's like
not still not quite right. No.
no, it's more than not right. It's like a haunting
Yeah.
nightmare fuel.
Yeah.
But
Yeah.
but the thing that all I'm saying is that the thing that old school animation methods gets wrong, the AI gets right.
Yes,
And
we have
so
new things going wrong.
Right. Yeah, totally. Where people are, you know, yeah, it's horrible where they've got multiple fingers and all that kind of stuff, but they move their fingers or they move their face in ways that feel very human. And so I think it's because it's fundamentally coming at it from a completely different place that it is going to, and it's rapidly improving. Like when you go back and look at Midjourney 1 through 5,
Yeah.
it's just incredible. So I think that we're going to get to this place very soon where the AI will be this tool. Like, have you seen, there was a, where people are like the equivalent of rotoscoping, but they're using AI to rotoscope on top of, like
Cities.
some video that they've shot, right? Where
Yeah.
they've animated over top of a piece of video with AI,
Yeah.
and it looks fantastic. And so right now, like you can have a live performance and have AI that's on like turned into any kind of anime or whatever you want, and it works really well. So I think, all this is going to get sorted out in like 2 years. We are just 2 years away from this all becoming pretty seamless at this point.
I think that where it's going to take longer is micro expressions. And people who aren't sensitive to micro expressions will have a better experience faster. Hold on, I'm getting asked a question, I think. Just a second.
By a dog?
Mute. No, my husband. Hold on.
Oh. Yeah, the Amber franchise. What were the Nine Princes in Amber? I should reread those. Those were so good. Delaney, right? Yeah, Roger Delaney. Yeah.
Okay, I'm back. Sorry.
Yeah. Yeah, I mean, like, but I guess
Not letting me back.
it's not going to create a new stream, is it? It just says.
What did it do? It now says that we're back. I see us on Twitch. Where are we?
Yeah, someone just said yay.
Okay, we're good.
Yeah.
That worked.
Yeah. Whew. Yeah. So all I'm saying is that I think the AI picks up things that feels a lot more similar to the way the human eye, the way our brains pick up things. Like, do you remember those first hallucinations by AI of cats, and they were like these weird kaleidoscope cat nightmares, but they definitely looked like cats. Like you saw cats.
Yes.
And so I think it's coming at it fundamentally from a different vector. And so the outcome is going to end up being different, and it's also accelerating. So I think it's going to get to a place of acceptability way faster than anything else we can try to do manually.
Based on having lots of training data. That's
exactly it. Yeah.
I remain bitter and pissed off because I submitted a grant in November, 2 weeks before ChatGPT came out, before the word generative AI was trendy, to do citizen science for machine learning, where the goal was to have everyday people look through astronomical data of fields that couldn't yet be classified by computer algorithms. And I discussed different kinds of AI, but never used the phrase generative AI because it wasn't a thing. And the grant was rejected based on, well, why can't this be done with generative AI? We don't need training data anymore, basically. And I'm like, generative AI uses all the training data, all of it. It doesn't just intuit out of nowhere.
Right. To make more. Like that's crazy talk. Anyway, we should get going with our recording.
All right. So
now, because you've got to go, you got a hard end at 45, right?
Yeah. I am pressing that record button. I am pressing that record button. We are recording.
Astronomy Cast, episode 686, Ice in the Shadows. That's right, 686.
Yes.
Yep. Okay.
Yes. Okay. False start.
Oh, well, maybe. Or I could just cut it up. Sure, fine. Astronomy Cast, episode 686, Ice in the Shadows. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. It is a Monday. It is nearing summer hiatus, which I am actually sad about because I do enjoy getting to hang out with you every single Monday. But at the same time, like, my yard is green and it is warm, and these are all good things.
Your bike is calling to you, and
Yes.
I'm exactly the same way. That there are all of these things, like my dad wants me to come over and visit.
Right.
I'm like, well, Dad, I can, but I'm busy on Mondays, and I've got to be near high speed internet, and I got this thing I got to do on Tuesday. I got an interview on Wednesday. I got this other thing I got to do, and then Fridays I do this other thing, and so nope. Now just day after day after day of internet free existence where I can do work, but
Yeah.
also be going places and seeing people. So no, I think it's great. I hope that we are an inspiration to all of you to take a break
Yes.
if you can, or at least get away from the internet if you can. Highly recommend it. But yeah, so we have this episode, 2 more episodes, and then we are on summer hiatus. So just like whatever you need to do to come to grips emotionally with what's about to happen, go to your happy place because it's coming. The permanently shadowed craters on the moon are the focus of so much research. That's because they seem to contain vast reserves of water ice, water we could use for oxygen, propellant, and so much more, but also to help us understand where the Earth's water came from. We'll talk about it in a second, but it's time for a break. And we're back. Why? How could there... I guess, why would we not expect there to be water? First, let's start with this. Why would we not expect there to be water on the moon?
Pretty simple. The moon doesn't really have an atmosphere, which means liquid will evaporate away instantly. The surface of the moon, when exposed to sunlight, exceeds the melting point of water. So if anything hit by sunlight melts, and anything that melts evaporates away, and there's no atmosphere, so anything in the very tenuous exosphere, it's not fully an atmosphere, will get blasted away by like solar wind and stuff. Water's not going to hang around in general.
And so why do we think that there are reserves of water on the moon?
Well,
or I guess, why did we think? So before we confirmed them, why did we think there were?
Good catch.
Yeah.
So it was realized that while our Earth is tilted about 23 degrees, and so as its orientation relative to the sun changes throughout the year, everything gets struck with sunlight pretty much. There's bottoms of wells and things like that can avoid it, but on the surface, you're pretty much good to go with everything will get sunlight. The moon, however, is only tilted like 1.5 degrees. And that little tiny tilt means that there are craters on the north and south pole that when you start working out the geometry and the depth of the craters, the sun literally doesn't shine there.
Ever. Yeah.
You
so
can
you've
go
got these
to the
craters
place where the sun don't shine.
Right. And it's weird because you can also go to the place where the sun always shines.
Exactly. So there are peaks at the north and south pole that are always in sunlight. And one of the coolest things about this is those regions that are permanently shadowed are like 25 to 70 degrees Kelvin, but they're thermally stable at super cold temperatures. And those regions that are permanently in sunshine, they're super hot, but again, they're thermally stable.
Yeah. All right. And so then how do we know that there is ice in these shadow craters?
Because we bombed the moon in 2009. Now, that wasn't the phrase that we used. That is the
Right.
phrase Twitter used. The Lunar Reconnaissance Orbiter didn't launch alone. It launched with a companion mission, L-Cross, where they essentially took a empty stage from their spacecraft, careened it into a South Pole crater that had permanently shadowed regions, and L-Cross followed in that stage, flying through the debris cloud, looking to see what was present and measuring as it went. And what it measured was hundreds of kilograms of water vapor in that plume.
And that was amazing. But actually, the first spacecraft to discover water on the surface of the moon was India's Chandrayaan-1 mission, which had a bunch of instruments on board, including a NASA instrument. And it was with one of those instruments they were able to detect the presence of water on the moon.
And that was a more tenuous. So that was looking at what is the distribution of, I believe it was neutrons in the surface, where when the sun has a flare, the high energy photons can cause neutrons to get bounced off. There are effects and things and stuff that the instrument can then detect. And because water is 2 hydrogen atoms and then that 1 oxygen, they tend to have a high ratio of neutrons to protons. And those neutrons can be knocked off fairly easily. So where you see a high density of neutrons beneath the surface, it is considered to be a reflection of a high amount of water being present. But the question was, is it water for sure? Is it for realsies, people? So it had to be confirmed. Right. And the other question was, so you can have water that is locked up inside minerals and not necessarily accessible. And so if it is water, is it accessible water?
Right. All right, we're going to talk about this some more, but it's time for another break. And we're back. So let's talk about, like, as you say, the presence of, the presence of hydrogen was detected in these rocks. And there were other substances, OH, for example, hydroxide? I don't think what it's called.
Hydroxyl groups, yeah.
Yeah. Like, there are other things that look like water, but they're not water. And, you could do some chemistry to turn them into water, but they're not just ready to melt and drink.
Right.
So I guess, when did we figure out with much more certainty that there is indeed water, both at the permanently shadowed craters and even other parts of the moon?
So,
as you say, we excavated some, we detected some.
So L-Cross was kind of the, yes, there is water that will end up in the plume created when you excavate into a permanently shadowed region. And since then, researchers have been working to figure out how to use different instruments to study how it is that water could first get to the moon and once there migrate so that it builds up in the permanently shadowed regions. Because you have 2 different problems to solve. The first is there actually water there? And then
right.
How on earth did it get there?
How on moon did it get there?
Exactly.
Yeah. So like, it's not permanent. It didn't form with the moon and just never got sunlit on it.
That is true. And then the other thing that we heard was, before it was understood just how common this is, it was thought that some of these permanently shadowed regions might have had water left over from whatever impacted into them, and that water was able to just kind of stay put, which really doesn't make a lot of sense.
Oh, like a comet smashed into a crater, and because it hit a shadowed crater, then the ice remained inside the crater.
which doesn't make a ton of sense when you think through that the formation of large craters, which are deep enough to have permanently shadowed regions, are going to end up with a lot of melting occurring when that comet hits the surface. And how are you simultaneously melting the regolith and leaving ice behind?
Right.
So
Right.
that
You're
get
melting rock, and yet somehow ice is not being thrown away.
right. So you end
Yeah.
up with this very special circumstance of something goes in, excavates the really deep crater, and then a smaller crater gets formed that doesn't actually melt stuff, but leaves the ice behind in the exact same spot. And it's just sort of like, that's a lot.
Yeah, like I'm imagining like taking your frying pan, putting it on a way too hot burner to the point that it's glowing hot red, and then you let it cool down. And you're like, whoa, there's water down at the bottom of this.
Hmm.
Like, if there was any water, that would have been the first thing to go. Like, your pan
Yeah,
melted
yeah.
because the water boiled away.
It's
So I guess, what do they think is the mechanism that got all of this water into these craters?
so this is one of the coolest things. I'm not a planetary science person, so I'm going to get excited about weird stuff. And this is one of the weird things I get excited about.
This is great. You can be forgiven. Yeah,
So
this is
so
worth getting excited over.
so water gets to the moon via an impact. That part is correct. Now, it also doesn't stay liquid water. It ends up in the moon's exosphere somehow. So you either have very small object with water strikes surface, ice ends up on surface and gets touched by sunlight. And the moon doesn't have a thick atmosphere, but it does have particles that float around. Exosphere is the word I've seen used a lot. And so these
Mhm.
water molecules will rise up into the exosphere and kind of drift around along the surface and then settle back down, remelt if they get touched again by sunlight, float around. And there is the ability for the water to random walk itself into these permanently shadowed regions and then be
Hmm.
like, no sun, I stay here. And I just
Wow.
kind of love the fortuitous nature of this, where
So
if you,
hold on. So you've got these comets blasting into the moon.
uh huh,
They're creating this very tenuous
uh
atmosphere
huh,
that contains water particles,
yeah,
and they are vaporized, and they are going around the whole moon,
uh huh,
and then they wander into this permanently shadowed crater, and they go, "This is home now. This
yeah.
is where I live."
Now, not
And they
all of
just
them.
and they snow down. No, some percentage of them, and yet in
Yeah.
astronomical deep time, snow drifts form over long periods of time. Like even like in some of the driest places in Antarctica, where you've got these kilometer deep ice sheets,
Yeah.
they only get a couple of centimeters of snow a year, and yet it
Right.
just builds up over long periods of time. A million years of snowfall at that rate gets you somewhere.
The fullness of time is a really amazing thing, and the randomness by which the universe is capable of accumulating ice in permanently shadowed regions is just really kind of fabulous.
Yeah, yeah. All right, we're going to talk about what we can do with this in a second, but it's time for another break. And we're back. So, the focus of a lot of the nations of the world in their space exploration plans are to go to these permanently shadowed craters of the moon. The Chinese are planning a sample return mission from the South Pole of the moon. They're planning to send astronauts to the South Pole. The Artemis mission, when they go back with Artemis 3, they're going to go to the South Pole. Like, this is going to be the place.
Mm-hmm.
Why is it so valuable to go to the South Pole of the moon?
Because there's ice, we think. And For All Mankind did an excellent season focused on this. The idea is we have the South Aitken Basin, which is a massive crater filled with craters. There's a bunch of permanently shadowed regions in here. There's over 300 known permanently shadowed regions on the moon as a whole, but the biggest are down in the South Aitken Basin region. And if you have water ice that is accumulating by basically falling out of the exosphere, it's going to be near the surface. There's going to be dust. There's dust everywhere on the moon. That is the nature of the moon. It's going to be like the end of winter snowdrifts that are completely covered in soot.
Right.
But that's accessible water without having to do significant mining. And
Yeah, I'd heard this estimate that, like, we know that there is water mixed in with just the regolith in general across the moon,
right.
but it's like a water bottle for a cubic meter,
And
which
that's a
is,
whole lot of energy to liberate
yeah,
that water.
right, to crunch it down, to boil off that water and get it out of there.
And so the question becomes, what makes the most sense? Launching water from Earth, flying it from Earth to the moon, and recycling it. And no matter how well you do recycling, there's going to be gradual loss. Then you also have the dig up a cubic meter of regolith, churn, get out not enough for one day of water. Or go to one of these permanently shadowed regions and hope for baby icebergs.
That'd be cool.
It would be
Yeah,
super cool.
yeah, 100%. So then I guess what could we use it for? We
Well,
got water on the moon. What
yes.
do we do with it?
So water breaks apart into two hydrogens, which can get used as fuel, and oxygen, which can get used as, well, we breathe it,
But also fuel, like
but also
the
fuel.
oxidizer for the, yeah, I mean, like the space shuttle was liquid hydrogen and liquid oxygen,
Yes.
water broken up.
Yes. And we need water to drink. We like to have water to clean. Water is a solvent that motivates so many different chemical reactions. Water really doesn't have a whole lot of limits on what you can use it for. Um, yeah, it is the bringer of life, the bringer of death if you get excessive amounts,
Right.
and will dissolve all sorts of things. It's
Yeah,
awesome that way.
dihydrogen monoxide poisoning.
Yes, exactly.
Yeah, yeah. And so, like, what would the future of space exploration look like if we're sort of starting to see into the far future here, and we envision, like, we've got, NASA has set up a base, some kind of research station near the moon south pole. The Chinese have done this. Maybe the Russians have got this. Like in For All Mankind.
Yeah, yeah.
So what are they doing to kind of turn these shadowed craters into a usable resource?
It's not too different from what we do here on Earth with water. You take the water there, you're going to have to heat it up into a liquid, and then you can use all sorts of various, basically electronics to zap it apart, process it into whatever you need. But the thing that is most interesting to me, once you ignore all possible political implications of battling over resources, we're going to ignore that part today.
Yeah, that will never happen.
Right, right.
Right.
So the moon is simply the nearest source of permanently shadowed craters. The reason it has them is that lack of tilt. And we have other objects with lack of tilt. The asteroid Ceres has permanently shadowed craters. Mercury, the planet
Nice.
snuggled up right next to the sun, permanently shadowed craters.
So same thing, like you could land a spacecraft on Mercury, just be bathed in sunlight,
Uh-huh.
and then just peep over a crater rim, and boom, it never sees the sun, and there is water ice in these. And this has been observed, right?
Yeah. And what's really awesome about these is on the moon, this is cool. On Mercury, this is transformative. If you build your habitat within the permanently shadowed region, it only has to be designed to either keep you warm. Well, really, if you're in the permanently shadowed region, that's all it has to do. It has to keep you warm. And you are hidden from so much of the direct radiation of the sun. And that's a major benefit. You're
Yeah.
not directly in that ionizing radiation. Then you have all of these resources there. And the top of the permanently shadowed crater is likely to have permanently sunny regions where there's so many different ways to generate electricity, not just solar power. You can start imagining in California, there's these amazing liquid sodium reactors that are now using. And you start to be able to imagine doing that kind of energy generation on the moon. Then add into all of that, now you can also do that on Ceres. You can also do that on Mercury. Now, I don't know
Right.
how you get human beings to Mercury in a reasonable way. I'm pretty sure that would kill us, but you can start to imagine getting a research robot there.
Hmm.
And
Hmm.
that's just kind of awesome.
Yeah, yeah. I mean, who knows? I mean, future missions, fully fueled up starships have a tremendous amount of delta V they could throw at it. You could get down to Mercury and set up shop.
It's that
Um,
radiation field that worries me.
the radiation field from the sun.
Yeah, on the
Yeah.
way to Mercury, because you have to get so close.
But if you're in a permanently shadowed crater on the moon, you are also protected from the solar radiation.
You just have to get there.
You just have to get there. Yeah, yeah. So is it really starting to feel like there are more, like it was always thought that the inside of the solar system was bone dry.
Yeah.
And then you get to the frost line, which is like the halfway point of the asteroid belt. And then the outer solar system is tons of ice. Like you look at the moons
Yes.
of Jupiter, there are huge amounts of water ice on them. The moons of Saturn, you're like all of it, the Kuiper Belt, like it's ice, ice, ice all the way out
Yes.
there.
Yes.
And yet, when you're inside, it's bone dry. So, is it starting to feel like there are secret hidden reserves of water that we just didn't realize were there?
I think a better way to put it is it looks like our solar system likes to throw snowballs at the inner solar system. And yes, a lot of things were on the surface baked dry, but we're now learning that on the inside they had water reserves. And
Yeah.
on worlds like Ceres, they're erupting, although Ceres is out past the frost line, so different science. But the outer solar system is definitely throwing snowballs, and
It,
we're keeping some of that water.
it's funny. Like an analogy that I always like to think of is like here, like during a long, hot summer, everything is bone dry, all the
Yeah.
plants are withering, but you move a log over and the
Yes.
ground underneath is moist still.
Yes. And you don't
There are
have to dig
plants.
very deep.
You don't have to dig. Yeah, and plants are peeping out the side of the log
Yeah.
because they're being protected from the evaporation, permanently shadowed, and so water can remain there for much longer. It's kind of amazing how much water is mixed in and locked away. As long as it gets protected from that
Yeah.
sunlight, then it's here to stay.
And our solar system likes to surprise us by doing things that we didn't used to think were possible. And it's going to make it easier for us to explore.
Yeah.
Although I'm sure there are other things that will counterbalance that also haven't been discovered yet.
Yeah, I mean it's such a gift that
Yeah.
you could launch a spacecraft to the lunar gateway area, which is like a gravitational halfway point between the Earth and the rest of the solar system. You you could have mining robots that are sending water ice propellant up to the gateway, spacecraft dock there, completely refill their tanks, and then do full burn flights to places like Mars or Jupiter or what have you, and significantly decrease the flight times to be able to do that. And it's like we have this the idea of this being the gateway, this being this
Yeah.
place where you refuel before you head along, is we're so fortunate, and this water ice is going to be the most important piece of the puzzle.
And I just want to make it clear, the key is the places that have these have no atmosphere. Venus does not have ice in permanently shadowed regions because atmospheres
Right.
are insulating. But
Yeah.
get rid of an
Yeah, but like what else have
atmosphere
you
and
got? Like Titan has
amazing
an
things
atmosphere and it's
happen.
got tons of water ice, right?
Titan doesn't exactly have an atmosphere that is above the temperature of freezing. So small
Right. So it
gifts,
works
small
works well.
gifts.
Yeah.
Yeah.
Yeah. All right. Thank you.
And thank you, Fraser. And thank you to all of the folks out there who are part of our Patreon. You lovely souls get this advertisement free. This week, I would like to thank BogieNet, Balazar Jones, Jean-Baptiste Lee Martin, Daniel Donaldson, Frank Stewart, Christian Golding, Will Hamilton, Michael Prosciutto, Javis Earl, Galactic President Scooper Star McScoops a lot. I love that name.
Yeah.
John Bays, Burry Gowen, Stephen Veit, Jordan Young, Jeanette Wink, Andrew Poelstra, Brian Cagle, David Truog, BogieNet, Gerhard Schwarzer, David Buzz Parsect, Zero Chill, Greg Davis, Laura Kettleson, Les Howard, Robert Plasma, Joe Holstein, Frank Tippin, Gordon Dewis, Adam Annis Brown, Richard Drum, Alexis, Felix Goot, Wanderer M101, Astro Sets, William Andrews Gold, Roland Vormerdam, Jeff Collins, Simon Parton, Kellyanne and David Parker, Jeremy Kerwin, Stuart Miles, Baltasar Jones. Thank you.
Thanks, everyone, and we'll see you next week.
Bye-bye, everyone. And then they saved.
Yeah.
And then Pamela went to the eye doctor. So we do have to cut things short today because my glasses are not cutting it. And so I'm going to go get a new prescription. And I'm going to aim to not destroy my neck with progressive lenses this year as I did last year.
It's great to have a goal.
No matter how ridiculous they are.
How infeasible. Yeah.
Yeah.
Getting old sucks.
Yeah. All right. So
you're gonna book?
Yeah. Any
Or
last minute words, thoughts? I have 2 minutes. 2 minutes.
You have 2 minutes. Okay, hold
2
on.
minutes.
James Dugan asks, would the water be radioactive?
No.
Could we drink it?
Yes.
It'll be fine. Yeah. So bombarding something with radiation doesn't make it radioactive.
Yeah, you have to have radioactive particles in it. That's why the
Right.
Fukushima nuclear accident was so bad, was there was actual nuclear stuffs in the water that was released.
Arjone asks, could you make a battery or engine based on the part of the machine being in the dark and the other part being exposed to the sunlight? Absolutely.
Yes, totally.
100%.
It is excellent. Yeah.
Luke Duke asks, could you dig your own crater and have ice build up over time? How long would that take? Oh,
Millennia?
but millions of years?
Yeah.
The
you don't
have
have
time
of
for that.
time.
Yeah. Sirius Kaylee asks, how long can ice last in near vacuum at 75 Kelvin?
Forever.
Without sunlight, I guess. Forever?
Yeah. There's no reason.
Like, I'm sure
for
there's
it.
like some amount of cosmic rays are bashing into it and photons from the cosmic microwave background, but
I'm just gonna
effectively
assume
it's
they're
building.
Yeah, they're getting more water molecules than they are losing.
Yep.
So yeah.
Okay. That's it. You got those are our questions, and go get your glasses done, and we'll see all of you next week. I'm doing my live show tonight, so come on back in a couple of hours.
Sounds great. And you're doing that
Thanks, everyone.
on YouTube?
Yeah, on YouTube. Yep.
Okay. I will see you. Bye-bye.
All right. Thanks, everyone. Bye.